Hello everyone and welcome to Webinar Wednesday. My name is Jeff Jezzard with Vector Construction and I will be your host for today. I am very excited to introduce a brand new webinar series brought to you by the Concrete Preservation Alliance, Strength in Repair, Next Gen Strategies for Concrete Longevity. This series dives into concrete repair solutions that are designed to equip industry professionals with the latest advancements and innovative methods to restore, reinforce, and extend the life of concrete structures. Today we are talking about transforming concrete repair, essential techniques for engineers, asset owners, and contractors. This is the first of a four-part series and will focus on completing proper repair techniques in alignment with ICRI and ACI standards and guidelines. Being aware and following these industry standards can help ensure quality repairs, long-term durability, and structural safety of your structures using proven industry methods. This program is brought to you by the Concrete Preservation Alliance. We are a coalition committed to advancing best practices in the field of concrete preservation. We draw on our members for speakers and presenters to provide education and awareness for the concrete repair industry. We'd like to thank our members and supporters from across the globe that make up the Concrete Preservation Alliance and make educational events like this possible. Here's a list of some of the Alliance members, which is continually growing, and thank you for their support. Sustainability is a big part of what Vector and the Coalition are all about. One of the biggest things we can do for our industry is to keep our structures in place, restore them instead of replace them. On the We Save Structures website, we have the Environmental Impact Calculator. If you're looking at a concrete structure and comparing rehabilitation versus replacement, you can enter the amount of concrete you are keeping in place, and the calculator will give you many facts for example, the conservation of natural resources, the avoidance of solid waste in landfills, consumption of water, and creation of carbon, for example. We encourage engineers and owners to use these types of tools when considering plans for their structures. If you registered for this webinar, you are probably familiar with our We Save Structures site at wesavestructures.info. You can find recordings or slide decks of all the awesome presentations that have been previously done. There are many great series you can find on bridge preservation, parking and marine structure preservation, concrete durability, non-destructive testing, and the design series. Also, please note our next session of this concrete repair series, which focuses on crack and void repairs using various injection and grouting techniques. It is of course on a Wednesday, Webinar Wednesday, and it is November 20th, so please log in and register as soon as possible. And finally, one last item of housekeeping. What we like to promote along with the webinar is the opportunity to ask questions. Just type your question in the chat area and we will do our best to get it in at the end of the presentation. We ask that you provide us your name and when you ask a question in the chat function. This is because we're giving away a $100 Amazon gift card, which you can see on the screen. This gift card is given to the best question and will be picked by our presenter, Alicio. So ask as many questions as you can. So now I would like to introduce Alicio, our speaker for today. Alicio Consultori is constantly involved in business development, estimating, and project management for Vector Construction, and has over 35 years of experience in the concrete repair and protection industry. Alicio joined Vector in 2009 as a division manager for the Southern Ontario Construction Office, and then served as the VP of Sales for Vector Corrosion Technologies. Prior to that, he was with Master Builders, BASF Construction Chemicals for over 20 years. Initially as a territory sales manager, and then for the last 10 years as the Northeast Regional Sales Manager. Alicio currently sits as the president of the Building and Concrete Restoration Association of Ontario, and is also an active member of the International Concrete Repair Institute. Thanks Alicio, and good luck.
Thank you, Jeff, for that introduction, and thank you and good morning all, and thank you for registering for this webinar, and we'll get into it. So proper concrete repairs are not just about fixing what's broken. They are essentially for ensuring structural safety, extending the lifespan of buildings and infrastructure, maintaining aesthetics, and preserving property value. Neglecting these repairs can lead to escalating costs and severe consequences down the line. So these organizations, as you see here, have been in place at the forefront, advancing the knowledge, skills, and techniques necessary to enhance the quality of concrete repair, restoration, and preservation. We'll go through all of them. Here's our presentation outline. We're going to go through the preservation process, the guidelines and the codes, talk about removal, repair methods, curing, QA, QC, and some couple of important interesting case studies. Some or most of you have seen this slide. It's been around for over 20, 30 years. I've seen versions of it when I was with master builders. If you follow this process, you'll likely have a very successful repair. But today, we're going to just focus on the red box there, completing the repair. As you can see, there are many available resources to help you succeed. We'll touch upon all of these today. The ACI, ICRI, OPSS, and other ones. And again, we'll go through them. As mentioned, the concrete preservation process can be used to walk you through any project, and by following the process, you will almost certainly achieve the desired outcome. This process is also compliant with the ACI 562 repair code. These are pictures of the covers of the code and the guide to use the code ACI 562. The guide goes through ACI 562 on a chapter-by-chapter basis and then presents working examples of typical concrete repairs projects worked out using the code. The standard essentially covers the key steps towards achieving a successful repair. You go through the standard, encourages evaluation, which is important, and you end up getting a more durable repair structure. Other tools at your disposal are these technical guidelines and procedures put out by ICRI and ACI. ICRI has published quite a few guidelines such as epoxy injection for crack repair, concrete repair, safety, evaluation, repair materials, selection, and many more. These are available in English and Spanish and are a great resource. All kinds of them out there for you. For you Canadians out there, OPSS also offers resources to guide you through different repair procedures. This one here on the slide is one that I see often. It's for structural rehabilitation and concrete removal. There's also the U.S. Bureau of Reclamation. They're best known for the dams, power plants, and canals they constructed in the U.S., but they also have a technical service center that has many offerings, including concrete repair. Again, another great resource. And lastly, there's the Federal Highway Administration. They're an agency within the U.S. Department of Transportation that supports state and local governments in the design, construction, and maintenance of the nation's highway system, including concrete repair. Okay, so now we'll get into the doing. These are the key repair and restoration steps we'll go through today. Again, step by step, surface prep, rebar protection, the actual repair methods, curing, and QA and QC. Above all, when doing these repairs, there are safety considerations to adhere by. It's basically the law. In the US, you have OSHA, Occupational Safety and Health Administration. Here in Canada, we have IHSA, Infrastructure Health and Safety Administration, and I assume, I'm sure there's others throughout the world. And of course, a common one is PPE, Personal Protective Equipment. ICRI offers many guidelines on surface prep, arguably the most important step in a repair. So here you have one key one here, guide for surface preparation or concrete repair of deteriorated concrete resulting from reinforcing steel corrosion. And again, another one here is selecting and specifying the surface prep method, depending on the type of product you're installing. And here's a couple of more surface prep guidelines. One for rebar cleaning and the ACI one for hydro demolition. We'll touch upon that as well. And here are some key best practices for effective surface prep. Again, these are all available through the ICRI guide. You can see there's 3 or 4 important ones here. The cutouts, the proper configuration to get a good repair, abrasive blast cleaning techniques, and saw cutting and edge repair, the perimeter cutting out under the reinforcing steel, again to achieve an excellent repair. Not sure how many of you seen these chips, these surface profile chips. I mean, they're available through ICRI. They offer these surface profile chips. It's a good reference to compare or gauge what's being done out in the field. So if you ask for a certain type of prep method, it's done in the field, and you can go out with these chips and compare it, or just use your basic experience. Again, this is very critical to achieving a good bond to the substrate and a long-lasting repair. Here are the ICRI surface prep guidelines as required for the specific repair material. So, down the left you have, whether you're applying a sealer or down to a concrete overlay, and along the top it's the different type of concrete surface profiles to get required for those type of repair materials. And that's basically what they look like. CSP1 is acid etching, and then down to the most deepest one, I guess, if you will, is CSP10 for coarse planing. When doing a repair, it's important to saw cut the edges of the repair prior to chipping. Good contractors just basically do this habitually. When I estimate, saw cut, saw cut, saw cut all the time. This will contain the repair to your desired area and prevent feather edging on a thin edge. And you can see on the process here and the finished product, the edges are straight and square, and there is no flaking edges. Again, good contractors just do this habitually. So now you've marked out your areas, done the edge cutting and conditioning. Now you move into the concrete removal. And you can remove loose concrete with lightweight chipping hammers, create a rough surface, depending on what you want to get to. You can continue with bulk removal until the steel is the clean steel is encountered, and then a clearance around the exposed rebar, a minimum of 3/4 inch or greater, or 1/4 inch greater than the top size aggregate. Again, all in the guideline. The next step is cleaning your repair area. Usually water or sandblasting techniques are used for cleaning depending on what is required and the environment you are in. A good cleaning removes dust, dirt, and debris. It also removes any loose concrete created during the chipping process. Sandblasting often does the best job, but can be more challenging to do in buildings and enclosed areas. So you have to plan accordingly, provide heating and hoarding, or just don't do it. Do something else, as long as the debris is removed. And here's a couple of pics demonstrating abrasive blast cleaning and high pressure washing. There's also hydrodemolition, and under the right circumstances, it is very cost-effective method of concrete removal. This technology has advanced greatly over the years as it relates to the production rates, the water consumption, the water recycling, and noise levels. I recently estimated a project using this system on vertical substrates where you actually mount the equipment to the wall, and it is very productive on very large scale jobs. And run this stage, it's quite noisy. It does a great job. So here we have an ideal concrete repair. You can see the repair material, nice bond line, substrate, and important that the repair material is compatible with the substrate, and shrinkage, modulus, and thermal expansion properties. And you could see it all in the guideline as well. So now the next important step is selecting the best repair system for your project. As you can see in the slide, there's a lot of things to consider. So it's best to do your homework and get assistance either through your technical sales rep, a certified repair contractor, or refer to the guideline. Or most times it's just in the spec. As you can see here, there are significant differences in the requirements of concrete properties for new consideration versus a repair project. I mean, there's a lot more you could see on a repair material. You know, new construction is pretty easy. You want good strength, freeze thaw, slump, shrinkage. Obviously on the repair, there's a lot more factors to consider. The location of the repair can also dictate what type of repair material you need. You also need to consider what kind of environment the structure is exposed to. So for example, if you may want to consider a denser material with low chloride permeability and low shrinkage for a parking garage that's subject to high traffic and exposure to de-icing salts that we have here in the Northeast. Or alternatively, you could use conventional concrete and then protect it with a waterproof traffic deck coating system. Another important consideration is how much time you have to do the repair. If you need to do repairs on a weekend shutdown that needs to be open to traffic on Monday morning, that is, you may need to consider a rapid setting material that is ready for traffic in hours. Again, this is these are all mentioned in the guide. And again, you can get the help on this from your technical sales rep, your vendor, material vendor, that is. And again, ICRI has good and comprehensive guidelines for both application methods and the selection of repair materials. ACI also has many detailed guidelines for repair application procedures. All of these guidelines and procedures are a good starting point if you are looking for information on concrete repair and don't know where to start. Here's one of the guidelines for repair and replacement of horizontal concrete surfaces. Probably the most simplest one out there. Saw cut, pour the concrete. Again, ACI gives you this process or procedure step by step. And here's a couple of pics of a live horizontal repair. This particular one is at the Seven Sisters generating plant in northern Manitoba. They're basically cutting out and replacing a rail platform. The second last step is the actual placement. There are many repair methods, each better suited for a certain repair. Small overhead repairs can be patched using a trowel, and smaller beam repair projects may be easily completed with some simple form of work or dry packing materials. So that beam you see on the dry packing, say if it was hundreds of feet long, obviously this would not be a preferred method. You'd probably do a form and pump. We'll get into that as well. And here you see a couple of live examples of vertical trowel applied repairs. Again, experience here, the trowelman really helps, giving a nice aesthetic and nice job as well. Another method being used more and more these days is spray application. Both low velocity and high velocity are better known as shotcrete. Shotcrete is applying concrete projected by air to a vertical or overhead surface. The impact consolidates the concrete and creates an excellent bound. It's basically pounding it into the substrate. The benefit of shotcrete is that it's much easier and a faster repair. There's no forming required for this process, but you do need an experienced nozzleman and finishing crew. So here's some examples here depicting this process. And one key thing takeaway, you can see how far away that nozzle is to the substrate. So it's pretty high, but I mean, it is high velocity and pounding the product right into the substrate, achieving a good bond. Some other methods for larger repairs could be done by form and pour or form and pump, with or without pre-placed aggregate. Either of these methods can create a good repair, and usually a contractor may choose one or the other based on their experience or expertise. Here's a couple of pics. The one on the left being a pretty sizable form and pour, and the one on the right, a small form and pump overhead application into a soffit. So now that our repair is nice and clean and we are ready to pour back our repair material, before you do this, you may want to consider some form of additional protection to your reinforcing steel. Again, depending on the environment. As you can see, there are a few options. These are all options designed to protect, prevent, or at least slow down the corrosion process in the reinforcement, adding longevity to your repairs. So you can do nothing, the alkalinity of repair material protects the steel. You could put a coating on the rebar. You can put anodes in there, or barrier coating and anodes as well. Here are some corrosion protection products and systems. Simple galvanic anodes, more impressed current system. Again, this is all depending on application. And there are also some chloride, electrochemical chloride extraction systems out there for bridge abutments, things like that. Again, all depending on application. So here's an example of a galvanic anode installation in a patch repair. So here it says type 1A. The 1 stands for patch repair. The A is an alkali activated anode. And you can see on the pic, it's basically the anodes are placed on the perimeter of the patch to mitigate the halo effect of corrosion starting outside the patch because of the difference of electrical potential. Again, that's a completely other presentation. The repair material has now been placed, and now you should consider some sort of curing method. It's quite important towards achieving a successful repair. It's critical. You want to control the water loss, reduce the shrinkage, increase the durability, and maintain the volume stability. It goes right up, maintain right from the set, 24 to 48 hours, right up to 28 days. The concrete wants water in order to gain strength, or moisture, that is. Here are the most common curing methods. Wet cure, probably the number one. Wet covering. Formwork curing, yeah, you can leave the formwork in place. That is actually a pretty good curing system. There's curing compounds. These are topical applications. There's membrane sheets, absorbent heat, etc. Wet curing and actual leaving the formwork up is probably the more common ones. And of course, ACI has very good guide specifications on proper curing. Quality control. Throughout this whole process, it is essential to exercise a measurable level of quality control. The advantages are certainly worth the cost and effort. And again, it's essential, as I mentioned, for durability and success. And there's 5 main advantages. You enhance structural integrity, improve the durability, consistent performance, cost savings down the road, and there's also compliance with the standards and regulations, or basically following the spec. Here are several key quality control methods. There's simple inspection, step-by-step inspection throughout the beginning and the end. Material testing. You cast cylinders, if you will, or cubes, or air checks, if you will. You see in the top photo there. There's before and after photos. We as contractors do a lot of that. There's QA, QC plans and paperwork they have to fill out. And a pretty common one is bond testing, and we'll get into that as well. And there's standards for that, of course. This one pick here is a direct tensile bond test, probably the most common. And again, not to be repetitive, there's some really good guidelines to help you with your preferred quality control method by ICRI. And here's 3: ICRI, ACI, and the US Bureau of Reclamation. So if you're into quality control reporting, most of these guidelines can assist with QA and QC forms, as you see here with the simple cast in place. You can fill out this form. There's all kinds of these forms, all different types of methods. I know there's a real detailed one we use for concrete repairs, and a very detailed one for crack injection, right down to the material used, the pressure in the pumps, etc., that sort of thing. Again, they're all available. Running a little ahead here. So as we approach the home stretch, we're going to finish off with a couple of case studies. And this first case study is a project our BC division, construction division, completed on a parking garage in Vancouver. I'm going to say this is 3 years ago. The client had a slab that was cracking and delaminated and wanted it repaired. And as you see here, just for continuity and consistency, I have the ICRI guide there for cementitious bonded overlay. So the cracks and delaminations were surface imperfections in the top few inches. So they didn't need to replace the entire slab, just repair the surface. There was enough open space on this project to use a large ride-on milling machine, as you see in the pic, which made the surface prep much faster and created a much more uniform repair. These machines, they may appear expensive to rent or subcontract, but they do top side removal much more efficiently than conventional chipping. A 2-man crew prepared this entire area in hours, compared to 5 or 6 men using breakers or chipping hammers. Using breakers and chipping hammers, quite frankly, would be unthinkable. So this milling machine really paid itself off here on this project. So there was 16,000 square feet removed, down to about an inch or 25 millimeters, all controlled and consistent. Following the milling, the slab was pressure washed. We saw this in previous slides. It's either sandblast or pressure wash to remove any microfractures. This 5,000 psi or 35 MPa to clean it all out, making sure it's no microfractures are visible. So now we're into the surface prep of this case study. So the long open time here is important of the bonding agent. Sometimes bonding agents can be more of a bond breaker if they cure prior to the application of the topping. I mean, typically wetting the concrete and then putting down a cementitious slurry is the best bonding agent. Again, as long as it can be kept damp and not allowed to dry out. So here they used a breathable hybrid bonding agent with a long open time to allow for the topping installation. And again, this was probably the most practical method, a good practical method that is for this particular project. You can see how they roll it out and brush it in, nice and uniform, and they're probably pouring that same day. Some of these bonding agents are well over 24 hours or so. So you can, depending on the application, you can do it the next day. So here's the topping placement. So it was a high quality, low permeability concrete repair. Large area, as I mentioned, 16,000 square feet slab on grade. So after they placed it in their little forms, set up these forms here, so they obviously did it in sections, and then they used the roller screed to get it nice and uniform, and obviously to the desired thickness. So this is acting like a bulkhead, if you will, to achieve uniformity and the proper thickness. The curing, as mentioned previously, is very important, and you must ensure the blankets are kept wet over the duration of the curing process. So here they used a 7-day wet cure using filter fabric blankets for optimum curing. I personally prefer this method over clear polyplastic sheet, and trying to keep the water underneath. I mean, I'm not sure, and these filter fabrics are readily available. They're used for landscaping and holding back things, roadways or gardens or whatever. You probably most likely see them in black, but these are available in white. You just roll them out, and it's so easy for workers to just come back and hose them down with a garden hose and keep it wet, instead of lifting up the plastic. And then also this doesn't leave staining as well, like plastic does. Again, not sure if that's a consideration in this project, but I've seen that before. You get these staining effects or marbleizing effect. Bond tests are a great way to ensure the overlay is securely bonded to the substrate. The bond test is a direct tensile pull-off test in accordance with ASTM C1583, which is the test method for tensile strength of concrete surfaces and bond strength or tensile strength of concrete repair or overlay materials. So it's a good system. You basically drill right through the topping, glue on a dolly. We'll get into this, and you're testing for the bond strength. Here they average 2.5 MPa or 360 psi. That is quite good. They did a real good job here. That is really good, actually. And here's a schematic of a direct tensile adhesion test material, apparatus, that is. A successful test is when the failure occurs below the epoxy bond line with a minimum reading. And again, this is what we see out in the field of 145 PSI or 1 MPa. This one here is a larger one. I've seen smaller ones that just a good job. It depends on the dolly size you're using, but you basically attach it, and the device is basically handheld, and after the epoxy is cured, the epoxy be cured within hours, or most times we go the next day, and you hit the button, and it'll measure the reading till failure. In other words, the dolly is pulled off. And so here we have the project successfully completed. It was a tight schedule, and to this day, I'm told it's performing quite well. Our next case study is a food manufacturing plant, and it's a soffit and through slab repair. Actually, both of them were soffit repairs, but the one on the right ended up being kind of both soffit and through slab, and I'll get into that more. And this is a food manufacturing plant in southwestern Ontario in Canada. And this is their packaging area, or was in their one of their packaging areas, where there's apparent spalling of the soffit in various locations, and obviously they were quite concerned about spalled concrete falling on the conveyor belts and getting into the product. Obviously a huge no-no and intolerable, if you will. So now the prep. Here we have the saw cutting, just more on the right, and the chipping. The area had to be hoarded off, and support scaffolding, engineered support scaffolding was put in place. We had to move around conveyor belts and that. And you can see how the chipping hammers, this is real cool to see as it relates to the safety I spoke to earlier. You can see how the chipping hammers here are supported. I don't know if any of you used one of these. They're quite heavy. For these younger guys, maybe not as heavy as for me, but if you're doing this all day long, you could imagine, in the second half of the day, how the production could go down, and these guys get tired and maybe cause some injuries. So you can see here they're hung, and the guys are working productively and safely, throughout the duration of the prepping process. So the preparation is done, and now the smaller, this we're referring to the smaller soffit area, is prepared, formed, and ready to pump for pumping overhead. So here the client opted for the galvanic anodes, to prevent any corrosion on the perimeter. Again, a whole presentation on its own. You can see here the guy or one of the workers is prepping the concrete before the substrate, getting it nice and wet and surface saturated, so that you have good adhesion. And right here you have the forms set up, and you have two nozzles, one for one for pumping, and the other one for releasing air and product. So this is a small area. They're probably just pumping in one, and then one product comes out here. They close off this and maybe top up over there. So it's a small area, pretty straightforward. And in this, we used a non-shrink grout with just fines, not too much aggregate. And this was actually done with a hand pump, very effective. So now the forms are removed and the repair is completed. Here removed, the guys taped it off, a little bit of grinding, maybe some patching here where the nozzle was. This little thing here is where there was a sprinkler, a fire suppression sprinkler taped off. So there was space here to paint. And the guys painted it with a breathable elastomeric coating to match the soffit. So the other larger soffit area, soffit repair, actually turned into a through slab repair. And we think what happened here is on the top side, this side here, obviously, there was some cracks we saw there. And then, you know, again, this is a food plant, so they got to keep it clean. And they're obviously continuous in cleaning with, you know, cleaning products, most likely seeped into the concrete cracks and corroded the reinforcing steel, which led to the spalling concrete on the soffit side below. So our guys basically, when we started here, you know, the guys, as you saw in one of the previous slides, they're setting up, you know, just to do a soffit repair. So this, no more than an 8-inch slab, it might be less than that, but anyway, they're chipping away and boom, they pop through onto the top side, you know, this one little hole, then they keep chipping away, and they'll keep chipping till their breakers hit really, really hard and sound concrete. So this was extended quite a bit. You can see right here. So here's the formwork setup from the soffit side. Again, all hoarded out. And so going back, it was just that rectangular area. You'll see a picture of it that had to be formed from the underside. And again, so now we are not pumping, we are forming and pouring from the top side. The repair mortar used was a low moisture, rapid setting form in place material. And again, we were under the gun here to get it done. And so this material was, you could waterproof it within as little as 24 hours. And again, we had really good conditions here. You know, it was obviously in a nice temperature. This was done in July, so we had to put extra guys on this to mix it and place it to ensure it wouldn't kick off in the bucket. And this particular product that was already extended, pre-packaged with aggregate, 10mm stone, 3/8 aggregate, and if you don't have enough guys on this type of material, I mean, it can really take off on you, and you don't have a nice finish. As you can see here, the finish isn't the best, but it's such a small area, the guys ground it down nice and flush, you know, ready to be waterproofed on top. It probably moved from this way to this way here, and you know, things are heating up here. So something to take note of. And you can see on the right, curing, a little bit of curing here so you don't get any cracking. And then the next day, they ground down that rough area, including the whole entire area, to get a nice profile. And they put down a traffic bearing 2-step system. The membrane was a flexible membrane, a primerless system, fast set. And then the next day, or they probably even done it a long day, later in the afternoon, they put the traffic bearing, or the top, the coating, the traffic bearing coating. And this was just pedestrian traffic, so they only put one coat down, one heavy coat as per the specification, and broadcast a little bit of sand in it, just enough for the client to able to clean it effectively. And on the bottom side, the left pick has a traffic bearing. Sorry, on the right side, or on the soffit, we use the same breathable elastomeric coating as we did on the other smaller soffit. Again, turned out nice. We'll probably be back here to do more soffit work. Again, it all only can be done on shutdown. And with that, I am done. Thank you.
Thanks, Alicio. Great presentation. Really like how you hooked everything up with the ACI and ICRI standards. That was probably the main point of the presentation. So now that we're done, we'll get to some questions that have been asked by our audience. There's been a whole bunch of questions, so thank you everyone for chiming in. I'll read as many as we can, and I'll let Alicio answer them. I am going to answer the first one, though. Someone did ask if these slides will be shared, and yes, they will. This entire presentation and these slides will be shared on the wesavestructures.info slide, and I'll put that up later as we go. But I know the reference to these materials, there's a lot of references you made, Alicio, and there's obviously so many different things that ICRI and ACI have to offer. So those can all be found, and they're where you reference them is on one of the slides. So it's, I think, icri.org and aci.com. So those slides will be shared. So to some questions. Here we go. Is it always necessary to remove concrete behind corroded reinforcement bars during surface prep? This is because normally, if it's sound, do you need to remove it, or is there other options?
Again, depending on, I'm doing a job right now where the answer is no. And the answer is no because of the conditions and the cost, and the consultants deemed no. But most time, probably 80–90% of the time, yes. And there's one of the slides there where most consultants want to stick their finger under the reinforcing steel. And the reason for this is you don't know what's under that bar. So you want to get under there, stick your finger there so that the sandblast nozzle can bounce off the concrete and get the bottom of that rebar.
Excellent. Here's kind of a controversial question in the industry, Alicio, and you can answer it as you please.
Give it a go.
What do you think about the use of epoxy coated rebars? I've encountered mixed options due to the potential for damage to the coating from storage and handling, etc., which would accelerate the steel deterioration compared to an uncoated bar. What do you think about this? So on mass pours, bridge decks, things like that, quite frankly, I don't see it much anymore. There are some DOTs in the US that are still using it. Our MTO here, I think, is kiboshed it as well, just because of the defects that you get when placing it, and then it could create a hot spot, create more corrosion, again, in an area where you may have low cover or something, or road salts get to it. Now on restoration, there are a few consultants that still use it. The contractors don't like it. I think it adds cost to it, but they inspect the heck out of it, so it's done properly. They go there with their kind of one of those dental mirrors, and they check to make sure that the epoxy coating is uniform and done properly. So I guess if it's controlled, sure, why not? Some other consultants don't require it at all. They use silica fume concrete. They may use anodes or good cover. Probably the best, good cover or waterproofing. Hopefully I've answered the question. But No, good answer. Thank you. It's a tricky question.
It is a tricky question.
Here's another one. How do you specify or determine the area of repair? So when you're talking about cutting the edge of smalling concrete, how do you determine how far or how big to cut before you chip?
Yeah, good question. Again, most time that's in the spec. That comes, that's, you spoke about other presentation, that's covered all in an evaluation and testing. But most times you can do one of two things. You can chain drag it, hammer sound it, and then spray paint it. So the guy will hammer sound an area and then maybe go outside that area 10 to 15%. I'm actually doing a job like that. You can do a ground penetrating radar and looking for intuitions, if I'm saying it properly, and then you can mark it from there. Or you can just see the spalled concrete and mark it. But hammer sounding, GPR, probably the best.
Okay, great. A couple more here.
Yeah, carry on.
Sorry, I'm reading a whole bunch. There's a bunch of great questions here, so I'm just kind of going through them.
All right.
When you have some good videos and you talked about hydro demolition.
Yeah.
Is there a controlled depth? Can you control the amount of concrete that's taken out, or is it just whatever happens, happens? It looked like a big machine, so.
100%. So you control it. Again, I'm not an expert. I've just seen this. We've used it here to remove coating, which does a great job. Basically, you set it. It's like a computer on wheels, a loud computer on wheels spitting out water. So you set it to whatever depth you want, and it moves along accordingly. That's it.
Yep. Here's a really good one, and it's going to set you up. But what is the most common repair installation failure method? Do you see curing, debris, influence the bonding, damaged reinforcement from removals? What do you see in your industry as the biggest problem for failures?
Bonding. Bonding.
Do you think that bonding is because of the surface prep, or is it more curing?
Yeah, surface prep. Sometimes not the right repair material, but bonding and not the right product. So bonding resulting from poor surface prep.
Perfect. Couple more here. We have just a few more minutes. In your experience, have you seen these guidelines used by many engineers? Do you see them in many specifications, or is this usually driven by the contractor?
The majority, yes. So, I would say, again, depending on the there's a small portion of our jobs that are, we're following a specification. But again, those ones that were working private for a client, we're just doing this, again, I hope I'm answering, we're just doing this habitually because we've learned using these guidelines in the past, we show up, we saw cut, we chip, we get under the rebar, we blast, get the right repair material and go. But most times it's out there, and depending on where you are in the world, up here they use government jobs, they use OPSS, some of the consultants, private jobs for condos, they basically mirror the guidelines on that ICRI surface prep. But I don't know, hope I've answered it properly.
You have, yeah. One quick last one.
Yeah.
What is the most preferred method of curing for dry pack application? Since it's probably not like a blanket or something, what would you suggest for dry packing?
Curing compound.
Good answer. Well, we have a few minutes left, and I think we're out of time here for questions, but we will be passing these along to Alicio after. There's still a few that we haven't got to, but he will get to them and email you back if there's any answers you haven't gotten. I'd like to thank you, Alicio. I guess it kind of proves that we're not alone out there, right? We have resources, and that's probably the main takeaway from this presentation is all the different guidelines and things we can use. We're not alone to make these decisions by ourselves, right?
Mm-hmm.
Yep. So if you think of any more questions, Alicio's contact information will be shared. And like I said earlier, these slides will be on the We Save Structures info site and along with the presentation. So if you have not done so already, please register for our next session in the series. It's called Mastering Injection and Grouting, Extending the Life of Your Concrete Structures, with our expert Mike Kernan. So if you'd like to register now, please scan the QR code, which you see there, or you can go back to our We Save Structures info site. Again, like we talked earlier, it's on there and you can register for that. And I would just like to reiterate one more time, there's many references Alicio made to testing and corrosion. There's many webinars that we've done already that are on that site with some really good information. So finally, thank you, Alicio, for this awesome presentation, and thanks everybody for attending. Now let's get out there and save some structures.